Just said that another way to think of this is as 1/2 mv squared over 2 is the same thing as 1/2. So I could multiply both sides by 2, or I could just put a 2 here and multiply by 2. So I get 2k equals, there go die, mv squared. But I'm still trying to get v by itself. Why isn't v by itself yet? There's two reasons, but go ahead.
The m.
The m. So I got to divide by m. Die. So now I have v squared equals 2k over m, but the v is still not by itself. Why isn't the v by itself?
Exponent?
That's right, because of the exponent being squared. Now, what is the opposite of to square something?
Not square something.
Square root it. So what I'm going to do is square root and square root. So I get the square root of 2k over m equals v. And that's the answer. And I had not yet, the other day we went through these, and we ended up a little bit short of the square root question. So this is the first one you've seen with a square root, and now that you've seen it, it's really not a big deal, okay? Just be comfortable with it. And I think we're gonna do one again tomorrow and one the day after that, so certainly by the third day, we should be good enough with them. Okay, any questions? All right. Now, like the lesson from yesterday, today's lesson is nothing new. We're not covering anything new, which is why I can take a minute or two to mention Ziva's puppies and stuff. All we're going to do is just think about what we've been doing. That's it. Nothing else. So there's no need to be overly stressed here. Publishing company orders black and blue ink in bulk for its two-color printing process. To keep things simple with its ink supplier, each time it places an order, for blue ink it buys B gallons. So capital B is for blue. And then for black, capital K. Obviously, you don't want to use B. Over a 1 month period, the company places M orders of blue, N orders of black. What quantities could these represent? What do you think M plus N is? Well, what does M represent again? The number of orders of blue. And N represents what? Number of orders of black. So what is M plus N?
The total number.
Total number of orders. Good. Now the next one says MB plus NK. What would that be? Let's break it down piece by piece. What's MB? M is the number of orders of blue. And what is B?
The amount.
The gallons, the amount of blue. So when I do M times B, I'm figuring out the,
Amount of stuff you're
the total number of gallons of blue. So what's N times K? Total number of gallons of black. So if I add up total number of gallons of blue and total number of gallons of black, what do I get when I add them all up? Total number of gallons. Good. Now notice this is, we just said, total gallons. And this was number of orders, right? So what do you think the top divided by the bottom is? Go ahead.
Amount of gallons for each order.
Yeah, the average number of gallons per order. Okay? All right, now part B. The company placed twice as many orders for black ink than for blue ink in January. Give interpretations of the following expressions in terms of the orders placed in January. Well, M over M plus N, and this one, what I could say for sure is that the guy on the left, because M was blue ink, right? Right? Had to be greater than the other one, okay? That's the big thing I have to say, because they placed more orders. All right, now, consider this statement. 2 plus 3 equals 1 plus 4. Y'all agree with that? Right? What's 2 plus 3? And the whole class said? 5. What's 1 plus 4? The whole class said? 5. Nice. So 5 is equal to 5. So clearly, this is true. When it says what is the verb, what we're doing here, the verb would be equals. Right? Equals is a state of being. Are they both equal to each other? I guess the subject would be 2 plus 3 and the object 1 plus 4. Is the sentence true? Yes, that's the big thing. Consider the statement 2 plus 3 equals 9 plus 4. Is this true? No, 2 plus 3 does not equal 9 plus 4. A number statement is a statement of equality between two numerical expressions. A number sentence is said to be true if both parts are equivalent. Okay? It's false if they're not. So let's go take a look at some very, very simple things. What's 4 plus 8, everybody? 12. What's 10 plus 5? Are they equal? No, so it's false. What about a half plus 5/8? You guys must love that one.
Oh, yeah.
And 1.2 minus 0.75. Now, off the top of my head, I would not know if this is true, but let's all do a little fraction work on the calculator to make sure that we can do this. So, I want you to do 1/2 plus 5/8 on the calculator. 1/2 plus 5/8. We come up with 1.125, I believe, as a decimal. And then if I look at this, I also get 1.125. So it is a true statement. Are we good? Okay. 9/8 is definitely the way to do it in our heads and so on and so forth. All right, next. Is the next sentence true? Yes or no?
Oh, apparently it is.
Yeah, what we're doing here is we're doing both the associative and the distributive, commutative properties. First off, can you see that the 71 was in the beginning and then it ends up in the end? So that's commuting, switching, okay? And then the 603 was being grouped with the 71. Now it's the 5876 being grouped with the 71. So that's the associative. So because the commutative property with multiplication is always true, and the associative property with multiplication is always true, and these are all the same numbers on the left and right side, then the whole thing is going to be true. What about letter D? Is that true? Can we think of why it's true? Francesca looks very out of it today. Why is it true, Ivy? Well,
But like, because 90 plus 85.
adds up to,
175.
right, so the 175 was broken into two parts, and I'm distributing the 13 to both parts of the 175. What do you think about letter E? See if that's true.
Isn't that
Definitely not. Agree?
Yes.
Okay, I would like to dedicate today's lesson to Mr. Frank.
Yay.
The reason I would like to do that is there are two things Mr. Frank loved to do. He liked to graph, and he loved to check. And I am not big on checking personally, but what are all of these problems really about? Checking, okay? So you had a great teacher of checks last year, Mr. Frank, and I'm sure that you remember how to check, and that's basically all you do with this. So true equations, check. And what do false equations do? Do not check. It's as simple as that. Any questions, everybody? All right. Very, 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 very good. Tomorrow we start more glorified new stuff.